Okay, thank you. Thank you, Christian. So hello, everyone. So today I will talk about thematic maps with R. And my first question is thematic maps with R. Why? So my point of view is that maps, as other graphics or statistical outputs, are part of scientific studies. They are produced with data. They are used in scientific thinking. So they should be also reproducible. So I have a background in cartography and GIS. And when I started to create maps and to think about reproducibility, there was a problem because many maps produced in an academic context are made with several softwares that use several data formats, that use several licenses. I mean, some of them are you need to pay for them. Some of them are discontinued. So here it's like graphics. When we used to grab the data with a browser, then the data cleaning is with Excel, and then data analysis with another software, and the mapping process with ArcGIS or QGIS or any other mapping software. So this multiplicity of different software products and formats and files on your computer, it's an impediment to reproducibility, because at each step you may have a problem and it's difficult to reproduce. So my point is that to be fully reproducible, maps should be associated with code and data. So this is a well-known figure from Roger Deepank, adapted to the map process. So a map that is not reproducible is just an image of a map. You can add some data sources, you can add the data sets, but the gold standard, the so-called gold standard, is to have a map that is kind of executable with the code and the data and the metadata, etc. So that was the problem as a cartographer. But if we go on for another point of view, the point of view of a cartographer, but who like to create maps, maps are not like any other graphics. There are some differences. There are some different rules to go from the data set to the map, to the figure, let's say. There are some rules, and the classical packages in R to create figures are not specifically adapted to geographical data. So there may be a problem to find the correct solution to create map. So of course there is a solution, and the solution is to create the map entirely in R and to use the spatial ecosystem of R. So here I can gather data, clean the data, make my analysis, and like a lot of different kind of analysis with R, and I can create maps with R. Thanks to a spatial ecosystem, meaning a set of packages that work together, and the R ecosystem, the R spatial ecosystem is exists since, let's say, the beginning of R, with some packages like Spatial, Geostat, Splank, and so on. So that exists before 2003. And then a first package, very important, was GDAL, which is a bridge between R and GDAL, a well-known library used to import datasets and change the projection and so on. And then many other packages appeared, like SP. SP was a package useful to map the geographical features and to manipulate the geographical data. And then our GEOS in 2010, which is useful to create all the geoprocessing analysis, like intersection, buffers, distance calculation, etc. The same year, there has been the release of raster. Raster is a package useful to treat and to deal with images from space. And all that ecosystem, raster, GEOS, SP, was the well-established base for data treatment, geospatial data treatment. And then in 2016, SF appears, and it was a huge change that is a lot the process of map making and dealing with geographical data. And as you can see, there are a few names that appears, and it's Edzer Pebesma and Roger Vivant and Robert Ishmant. So they are the three persons that helped a lot on these base packages. So this one are for dealing with the data management and the data treatment, but there are also some packages that are specifically dedicated to thematic cartography, so to create maps. And the principles, the main ones are TMAP, ggplot2, plus ggspatial and other like ggmap or so on. So it's possible to create maps with ggplot. I said earlier that classical graphical packages are not well appropriate to create map, but it's possible to do it with ggplot2. And then there is the Mapsf package, which I created, and which supersedes cartography, which was a previous attempt to create a package for cartography. So it's for thematic cartography. If we think about interactive cartography, there are also several solutions like Leaflet, which is based on the JavaScript library Leaflet. There is also the MapView package, which is based on the Leaflet package, which is based on the Leaflet.js library. And there is also MapDeck, which can be useful and use another backend, Mapbox GL and DeckGL. So this part is for the mapping process, but there is a lot. I mean, a lot of packages that are dedicated to spatial statistics and how to use the space as a parameter for models. So which with distances, and I just have put it some here, like SpatStat for point pattern analysis, and GStat, but there are many others that are dedicated to specific parts of
Uh-oh, did anybody else? I think,
Yeah,
Timothy, I think you've cut out a little bit. Hopefully he comes back in a moment.
cool stuff though. I want to look more into these spatial packages.
Oh, okay. Hopefully he comes back in a moment.
It's funny because I just tweeted a reminder saying it was happening now, but now it's not happening now.
It should be happening now.
Yeah, yeah.
Yeah, I also was like, I'm familiar with some of those packages, but not all of them. So I was kind of writing down the ones, you know, hoping like I'll go back to
Had I
them
been
and
in a
figure out what they
more
do.
Had I been in a more amenable position to write, I would have done so, but instead I'm just going to look at the video when you post it.
That's a good idea. Yeah,
Yeah,
I could also do that.
it's true, but
Oh, there we go. Let me, okay. You should still be a co-host, so
Okay.
I think you're back.
Yeah, thank you. Are we all set?
Yeah.
Okay. So sorry for the connection. And so
That's okay.
SF is used by a lot of other packages. So it's a quick overview of what SF can do. So for example, this is an SF object. So it's a spatial object. It's a data frame. It's a real data frame, plus some other features like a special column. In this example, it's called GEOM. And this column contains all the coordinates of the features that you may want to map or analysis. So it's the definition of the polygons, the points, or the lines. And there are also some information on the coordinate reference system. So maybe you have heard about WGS 84 or some stuff like that. So it's the way that you can display on a paper something that is a sphere. So we use coordinates, reference system, and transformation. So it's a package that is very simple. To import a data set, you have a function which is called st-read. All functions in SF start with st underscore. St stands for spatio-temporal fact. And with SF, you can also create some operation on the geometry of the spatial feature that you use. In this example, with the function st-centroid, you can extract the centroid of a polygon. You can also create distance matrices. So you have the distance between each point that you can use in statistics to compute the minimum distance from one point to all others, or some stuff like that, or create aggregations. You can work on the geometries and create some aggregation of the geometries, like you will do with group by from a dplyr. You can also create some buffers, so to create some space around the polygons. And in fact, all the classical operations in GIS are available through SF. So in this example, I create like a square named P, and I can cut with this polygon. I can cut another layer and obtain the intersection between two layers. And some stuff are more, let's say, involved. Here is an example when you start from a set of points and with the set of points, you can recreate some polygons. And I use this example to say it may not be easy, but I managed to find it on internet quite easily because SF is quite used, and so it's easy to find some documentation on it. And in this example, I use also the R pipe to show that SF is quite compatible with the pipe and quite compatible with all the diverse syntax. So you always have the first argument as a data set and so on. And with SF, you can also, let's not say map, but plot some geographic features. And as a cartographer, the second series of map here, these maps are not quite satisfactory because they are not using the proper language to display the data set. I mean, if I want to display a total population, I won't display it on surfaces, but in proportional symbols, for example. And it's not possible with SF, but it's okay. It's useful to quickly map the variables that you may have in your data set. So it's easy and it's useful, but it was not enough. So I've created the Mapsf package, and a typical workflow as you can think about is that you import datasets in R with SF. It can be geo packages or shapefiles or any other spatial data format. Then you can use some geometrical operations or statistical operation or geostatistical operation or anything that you can find in R. Then with Mapsf, you can create a map that you can output. The one here is an output of an R program. And if you want, you can open it in another software like Inkscape or Adobe Illustrator or so, to further modify it and make it look even better. The main function of Mapsf is mf map. So all function in Mapsf starts with mf and then underscore. MF stands for mapping feature. It was not easy to find a two-letter code that is not already taken somewhere else. So how does it work? You have 3 parameters. X, it should be an SF object. var, so it's the variable that you need to map. And type, it's the map type. If you may want to map proportional symbols or a choropleth map or a map of typology or symbols or colored symbols. There are a lot of types that you can use. And so it's the main function, and I try to keep the number of arguments low and easy to understand, I hope. What kind of map you can make with MF map? So you can just display a base map. So it's the equivalent of something like plot ST geometry or something, but a bit shorter. You can also plot some proportional symbols. So it's particularly useful for stock data, quantitative absolute data. You can create a choropleth map, so for ratios or indices or so on. Or you can create typology maps. Here you have some data that are qualitative, so it's names or categories or you name it. Or symbols, it's also for qualitative data. You can also create graduated maps. So here the sizes of there are 3 classes of symbols, 3 sizes, so you can use it to map like something like small cities, medium cities, large cities, or some stuff like that. And you can combine some representations. Here you can have proportional symbols that are filled the way they will be filled with choropleth maps. So it allows you to map 2 variables on the same map and to put them in relation. So the size is the quantity, and the color you have to qualify the quantity. And it's also possible with typology. So here the proportional symbols are colored according to a qualitative variable, or symbols. So the symbols are qualitative, and inside you can use ratio or indices. So it was the use of MFMap, the core of the package. But to create a map, you need to add some elements to make it more understandable. So some parts are really mandatory, like a title. So there is a function to create a title, MF title. You can, you may want to add a north arrow. So there is a MF arrow map. You can add credits or a scale bar. You can also add a shadow under polygons. It's for aesthetic purposes, but also it can be useful to underline something on the map. If you put a shadow on it, it makes it highlights it on the map. And you can add labels or annotations. And that's quite the main purpose of the package and the main features. So now I will go through an example. So this first part, the first line, MF get MTQ, is just to import the sample dataset of the package. Then MF map, x equal MTQ, you just plot the base map. If I want to create a choropleth map, I just add the name of the variable, med, it's the medium income, and the type, choro, for choropleth. So there are a lot of default values for each parameters that I try to make it the more versatile, let's say. And if you want, you can customize this first map using a different palette, a different color palette, using a different method to classify the data. Here we use the quantile, and we use 6 classes, and you can you can change the title of the legend, the rounding of the numbers in the legend, and the position of the legend. So here it's the map, the lowest form of the map, and it can be useful when you are just working on something. But if you want to present it to someone, you need to have a title, some credits, a scale bar, and a north arrow. So the functions are quite explicit. MF title is for title, MF credit is for credit, and so on. And so this is a basic map. And if you want, you can use some theme. Here I have just added one line with the MF theme function to use a cartographic theme. I will get back to this later. But here you have the background of the map, that has changed, and the way the title is represented and the foreground color. So it's useful it can be useful to have some themes and to change it to have a visual identity that is constant or that is adapted to your firm, or you may need to use certain colors and so on. There is also a feature that can be useful. It's the possibility to add insets. So to add cartographic insets, you can add a world map on the side. It's down here. I'm not sure if it's shown on the screen when I highlight the code.
We can see you're highlighting.
Okay. So this part, I start an inset. In it, I can add a world map, or in fact, any map. So I can add in it a map on a smaller area of the region, or a larger area, or anything, or a graphic, in fact. If I want to add an histogram or a box plot or something, you just start a small graphic device in the main graphic device. But as you can see on this map, there is an overlap between the world map and the main map. So there is the possibility to adjust the margin of the map. So here it's this part here with the mf init function. You can add a parameter called expand bb, that allows you to add some space on a side of the map or both sides of the map. So if you need space to add the legend or some comments or another map, so it can be useful. And I have also added a special function to export the maps, because it's possible to use functions like PNG or SVG or any base or graphics function. But I don't know if you have faced this situation, but when you export a graphic with R, you are never sure about the ratio between width and height. It's quite sometimes you have some huge space on the side or on the top of the figure. So in this function mf export, you start with putting the name of a spatial object and the figure that will be the output figure will have the same width-height ratio as the spatial figure. So you can be sure that the map will fit quite well in the figure without extra space on the side. So I said earlier that there are themes that are possible. You can use the built-in themes, but you can also customize them and change the position of the title, the size of the frame, and a lot of things. And there is a vignette in the package that is dedicated to the use of themes. Mapsf is focused on vectorial data, meaning polygons, points, and lines. But it's possible to add some raster images. So to add here in this example, it's some map tiles from Stamen Design from OpenStreetMap. It can be useful to have this on the back as a base map if you don't have polygons or a huge region. And the mf raster function is dedicated to displaying this kind of map. Around the package, there is a website built with, I don't remember the classical package dedicated to build website for packages, with some documentation, some vignettes on how to create faceted maps. It's not actual facets, it's just a trick to use a loop to create some maps in a graphic device, how to create insets, how to export, how to use a custom font family, or how to use stems. There is also a cheat sheet that is not very that may need some updates, but we try to put some to create this to have an overview of what the package can do, what are the kind of maps that you can create with. About the development of the package, the philosophy behind the package creation, I try to use a minimal number of dependencies. So I try to use the less packages as possible. So the main ones are SF, which was obligatory. And there are also RCPP to make some small features, and classint to create the classification of data. The package is on GitHub. It uses continuous integration and continuous development. For the test, I use TinyTest, which is an alternative to TestDat. And it's in the name, it's tiny. So the idea is also to keep the number of dependency as low as possible. And for this package, I started to use informative commit message with conventional commits. Conventional commits is a way to use Git, it's self-explanatory. So the commits are some rules to make it more readable for the public. So that's it for Mapsf. But for some smaller, some other kind of maps, I've created some other packages that are small packages, sometimes maybe 1 or 2 functions only. And the first one is called Tanaka. It's dedicated to the representation of a topography with the use of shaded contour lines, so-called relief contour or illuminated contours and so on. So this one is on the cron and in GitHub. And the idea, the map on the left is the default map when you try to plot a raster of here its elevation. And the use of Tanaka allows to highlight the relief feature and so on. So it's a very small package, but it can be quite eye-catching. I would say it can bring the people to watch your map with more interest, because it's not useful, not something that you see every day. So it's a kind of map that is a bit different. And it's not, you can use it with data that are not topographical or geographical purely. So here it's a map of the smooth population density. So it's not elevation or temperature or so on. It's a phenomenon that is linked to people. But you can show the relief of where the people are. I have also created a package called Line Map to create this kind of ridge line maps. So I know it's possible with maybe 1 or 2 other packages, ggplot and so on. But this one is quite old, and I'm not sure it was possible at that time. But anyway, you can create this kind of map that may not be the more efficient to tell to tell a message to another to your public, but it's quite nice to see, and surely the people are looking at this map. So it may not be useful to make very precise comparisons, but it can be useful. Another package is map tiles. This one is dedicated to the download and the composition of tiles from different providers like OpenStreetMap, Stamen, or Esri, Carto. and you name it, because you can also use any other tile providers that use the classic convention of displaying tiles. It can be useful to have a base map. If in this case, for example, the number of beds in hospitals in Paris, I only had the position of the hospitals, but I didn't have a base map of Paris or the roads or so on. So it's quite easy to just grab the base map from something else and to map it. And here it's an example of use where it's this part. You just indicate with the get tiles function the name of a spatial object, and it will download and compose the tiles. And then with Mapsf, you can use the MF raster function to display it. Of course, I try to make all not all, but most of the packages I use, I try to make them compatible and interoperable. But so here it's an example of some of the map tiles provider that are accessible directly from the package. Here it's another package. I'm not the maintainer of this one. I have just contributed to some methods in it. So it's the cartogram package. The cartogram package is useful to create cartograms. So in cartograms, you use a quantitative variable, some stocks, absolute quantitative variable, and you transform the shapes of the polygons to reflect the quantities in the variable. You don't add some symbols, you just transform the shapes. And there are 3 methods. So this kind of map are also very useful to catch the attention of the public, because they are not usual. They may not be that easy to understand if you don't already know the region that is mapped. In fact, if you don't know North Carolina and I only show you the map on the upper right corner, you may not understand what is larger, what is not larger, etc. So you need to know the region to make an efficient cartogram. And here it's a trick to use cartogram. In this map, it's a map of the number of person in the active population. In red, it's more blue collar than white collars. In green, it's more white collars and less blue collars. And in fact, you can see here around Montpellier or Toulouse, around the huge cities, all the circles are overlapping. With the use of the cartogram package, you can make them not overlap and make the map very more readable. So at the price of losing some precision in the position of the points, but the map is more readable. So there is another package called Fisheye. This one is used to transform base maps using log azimuthal projection. So I will explain. In this map, the map on the right, you have a lot of circles on around one specific space. The variable that is mapped is the place of residence of workers in a specific district in Paris. So where the people live, what the people who work in Paris live. So the idea is to use like a fisheye effect. So you select a point on the map, the gray part, and then the space is deformed around this point. And it's quite useful when you want to have a zoom on a part and to keep a context around it. If you look at this animation, so you go from a map that is quite cluttered when you cannot see very well where the people are. And then you have kind of zoom that keeps the context. So here it's an example of code. It's quite easy. It's also a package with like maybe 1 or 2 functions. And so the idea really is this one, that you go from try to use a logarithmic distance. So you have a zoom. This one is pop circle. So it's a kind of a new take on cartograms. So the idea is the same as the one of the cartogram. So you will create some circles that have an area that is scaled to a variable, and it's displayed using a compact layout. Sorry, to show the most populated or the most populated areas. So in this kind of map, we are on the data-viz side more than cartography. But anyway, it's a map. That's it. Then I have left the code of the map in it just to show it if someone wants to reproduce, and to show that is it use SF, it use some stuff from Mapsf and some stuff from Airbase, so you can mix all this. The last package is called Spike Map. So in 2020, I saw this map on the New York Times that showed, I think, the number of COVID cases. And I said to myself, oh, okay, it's possible to map quantities with circles, but also with square and maybe other simple geometric symbols like spikes. So this kind of map use spikes, proportional spikes. And it allows to create this kind of map that is not the same as line map, but in the same category, let's say. And you can create some good looking maps. And here it's the population of urban agglomerations. Or create a fire effect, I don't know, with overlapping spikes. So that's all for the packages. And then there are just some maps. This map has been done entirely in R. So there are no Adobe Illustrator or Inkscape or nothing. It's the output of an R program, where you can use SF to extract the borders between the regions, and then use SF to make a shift and give the impression of a physical border using a specific cartographic projection and so on. And this set of map, it's coming from the same data set. So the data set is not quite fun. It's the dead and missing migrants in the Mediterranean Sea. So we have for each event a point with a size. And from this data set, we try to create some different maps. So it was just to show you that with R, it's possible to create maps that you may not think that are made with R. And if you have the same data set, you can use several ways to map it. And these maps were there to show you that in a context where we had to use a specific template we had to use the blue lines, the position of the legend, the position of the credits. All this was mandatory by the contractor we were working with. And it was possible to create this map with R, with the logos, with all the stuff. So it's, in my opinion, it's possible to create maps that are quite complicated and quite constrained with R. So just to finish, it's some resources about spatial in air, not specifically maps, but there is the well-known, I don't know, well-known, but GeoComputation with R. It's a very good book by Lovelace, Novosad, and Muncho. All these books are really available on the internet.
Pero espérate, estoy en esta.
So this one is by Edgar Pebesma and Roger Vivant. So it's quite new. It's quite the book. There's this one that is based that focus on raster data. There is an article about the R ecosystem for spatial data specifically here. So maybe if you want to know more about the history and the future of R and spatial data in R, you may want to have a look at it. And in French, sorry, but with a colleague, we have made two books, not books, so book down, let's say. One about cartography and one other about geomatic. And if you want, there is also a task view on-prem dedicated to analysis of spatial data. There is a mailing list, and there is the R Spatial blog that can give you information about the spatial ecosystem around SF. Thank you very much. And at the end, there are some references. So thank you.
Thank you so much. That was a really excellent presentation, and I learned a lot from that. So I'm sure I speak on behalf of everyone when I say we really appreciate it.
Thank you.
I think we will have some time for a few questions and just discussion. Before we get into that and people start dropping off, I just want to make a really quick announcement that our next talk will be May 18th. It'll be at a slightly different time than normal. It'll be at 11 a.m. and it'll be about HTML and CSS for our users with Albert Grapp. So hopefully we'll see you there, and we'll get the information and registration details out to you soon. I did see one question in the chat, which was around the spike maps and I think the ridgeline plots. Can those be combined with topographic maps?
Yes, I think it's possible. The spikes and the yes, it's possible to add them over an existing map. So maybe raster or vectorial. It should be okay.
Okay. I had one question of my own, which, you know, as we were going, I was realizing once you got to the part where you were saying you work towards having minimal numbers of dependencies, I realized, okay, this is not in the ggplot2 framework. So one of the things I was thinking about is one of the nice things in ggplot2 is the way that it uses the scales package for formatting numbers. You know, if you want to format numbers and put like a $sign in front of it, or commas in it, and things like that in your legend or something like that, or in your axes. Is there a way to use those kinds of features in Mapsf?
Yes, I think if it's possible to use it without putting it in a ggplot function, I think it's possible just to in fact, I'm working like now on a specific package for legends. So in this package, you can use anything you want, any labels you want for the legend. So if it's produced with scale, it's produced with scale. So
Great. Okay, thank you. Yeah, there were so many things I noticed, like having the measurement scale, having the way that the legends were shown that were just, I think, done very nicely in Mapsf that don't come out automatically in ggmap or using just SF. So it was really nice to see those.
thank you. Yeah, the slides are already online. That's right. And of course, if you use the package and you find a bug or something, you can tell me it on GitHub. That's helpful. That's not an aggression or something. It's nice to have some feedbacks. And if you have some ideas to add to the package, I'm open also, because there are some needs that I may have not seen. Oh, I see a question in the chat about flows of people or goods. And it's difficult in cartography to map flows of people and goods, or to map flows, in fact. There are some way to use only a starting point and use proportional symbols to map the destinations, and to simplify the data to not create the lines. In fact, with Mapsf, you can create some kind of not flows, but links. So you can use proportional links or graduated links. And when I say links, it means that it's not oriented. It's A to B or B to A, it will be the same line, and there is no arrow on it. But it's difficult to represent flows on a map. It's difficult to, I mean, the idea is not difficult, but the software implementation is not there yet, I would say.
Okay. Yeah, my mind goes straight to those maps you see of flights where they have all the flight paths are drawn in like big arcs over the countries or the airports. But again, those aren't typically directional.
Yeah,
and they're really cluttered a lot of the time. You know, there's hundreds and thousands of lines.
Yeah, one of the main points when you want to create a map of flows is to work on the data, to simplify it, to select the flows that you want to represent. Is it the first 100, the first 10%, or the largest one? Or there are many methods to select the flows before mapping it, to avoid having like a spaghetti plate.
This conversation reminds me, I recently read a paper where to represent flow of infection, they mapped like a centroid over time and how that shifted. So the centroid would start at the source, but then as it dispersed, it would get more central, and it would grow in size based on the proportion of number of infections. So I think that's something that's trying to depart from that spaghetti like plate that you're describing, but it's difficult, especially if you have populations clustered in different places, if you're dealing with things. But just, it's nice to see that there's development and people are trying to come up with better ways to represent flows.
Yeah.
All right, well, I'll give it a moment in case there's any last questions that come up, but we don't have to stick around in silence if there aren't any. So if you have a question, yeah, now is your chance. otherwise, it was really great having you, Timothy. Thank you so much for coming. We'll
You're
work on
welcome.
getting the recording online, hopefully tonight. So have a great evening, and we'll see you all at our next event.
Thank you.
Have a great evening, and it was really cool to see all those packages.
Thank you. Well, thank you. Goodbye.
See you. Bye.
Thank you so much.